Hello guys, I've seen some of you have already done your Chapter 8 homework, which is great, but I just want to make sure we get the big idea of what's going on. So we're going to have some type of series, and remember, the sequence are the numbers. A series is when we add the numbers. So you'd plug in 1 to get 1 over 1 cubed, then you're going to plug in 2, then you're going to plug in 3 and 4 and keep going. So you're going to get 1 over 1 cubed plus 1 over 2 cubed plus 1 over 3 cubed plus 1 over 4 cubed. Now, the idea is this whole chapter is just to tell me whether it converges or diverges. So that's where this comes into play. All right, now we're not going to use them all, but we're going to use most of them. So I just wanted to start with Chapter 8, Section 2. So if you'll turn to the book, and I know you can pause this so it's easy for you to do. I just want to talk about this. They say verify that it's divergent. So if we want to look at this very first one, the first thing I do is I'm like, hey, if I have something to the n power, I go to the geometric series. Well, my base is bigger than 1, the absolute value of it. So that's the test right there. My base is bigger than 1, so it diverges. So that's what that tells me. So the reason will be that diverges by geometric series. Now the next one is 4/3 to the n. Well, that's the same exact problem. So 4/3 to the n, you can say, hey, immediately that's going to diverge by geometric series. Same thing with this next one. I have a number bigger than 1 to the n, so it diverges by geometric series. Now when I come to this one, the absolute value is bigger than 1. And if you look, that's what that test says. If the absolute value is bigger than 1, it diverges. So even though the base is negative, the absolute value of it's bigger than 1, so that diverges. For me, the first test I always look for is the limit as n approaches infinity. If I have n over n plus 1 in number 11, I know that limit is 1 because the degrees are the same and it's the ratio of the lead coefficients. By the kth term test or nth term test, whichever, if the limit is not 0, then it diverges. So this is going to diverge by the kth term test or nth term test, whatever you want to say. The reason being, once again, is if this is going to get closer and closer to 1, remember the series keeps adding it. So we keep adding it and adding and adding it. We're just going to keep getting bigger and bigger and bigger. That's why if the limit approaches 0, that's when we can say, hey, is it going to get small enough to where it's actually going to converge to a specific number? So once again, for this one, number 12, I would look at the limit and it would be, hey, it's 1/2, it's not 0, so that's going to diverge by the kth term test. Same thing here. The limit is 1, so it diverges by the kth term test. The limit is 1 because remember, the square root of n squared still has a power of 1. So the limit is 1, so it'll diverge by the kth term test. Here, it's going to be the exact same thing. If you take that bottom, you can write it as 2 times 2 to the n. So the top and bottom are growing at the same rate. So the ratio of the lead coefficients are 1 over 2. It's not 0, so we can say it diverges by the kth term test. And finally, in this one, just remember, n factorial grows faster than everything else. So this thing is going to approach infinity, which is not 0, so it diverges by the kth term test. Okay, in 33, hopefully you got 3/4. Remember, what you'd want to do is break that up with telescoping series. If you didn't get that, just let me know. All right, so let's go to 8.3, and let's just talk about a few of them real quickly. P series. So first of all, an integral test. So when I look at this one, 1 over n plus 1, I would do the integral test here. If you integrate it, you get ln of n plus 1. But when you put infinity, it's going to be infinity, so it's going to end up diverging. But you can integrate that. For this one right here, same thing. You're going to be able to integrate it. I'm not sure which ones I gave you on this one. But then that's how you do the integration. The next are the P series. So if you remember by P series, if your number is bigger than 1 on bottom, the exponent, then you can say that it converges. So if you look to the P series test, if P is bigger than 1, it converges. So 3 is definitely bigger than 1, so it converges. Or you could integrate that. I guess they wanted you to do that. But here it's quickly, you can do it, say, hey, it diverges because of the P series. So we want to do the quickest way. If we go to 13 and 14, 13 is n to the 1/5. So that's going to diverge because it's less than 1. But this is n to the 5/3, so it's going to converge. So that's going to be the P series. I think there's some good problems in the back here. So if we want to go to these, 53, that thing is going to end up, you can do a couple things. Later on, it's easy to do the limit comparison test. But right now, if you do the integral test, you're going to get that it diverges. For the next one, if we look at this, that's actually the arcsecant if you want to do the integral. I don't think I assigned that. I hope not. 55, it looks difficult, but you can combine that bottom and be into the 5/4. So it's bigger than 1, the exponent is, so it's going to converge by the P series. This next one, the exponent is less than 1, so it's going to diverge by P series. Now I have something to the n power. Now I look to the base. If the base is less than 1, we can say that it diverges by geometric. The base is bigger than 1, so we can say that it converges. Here, the limit is going to end up not being 0. The limit is equal to 1, so we can say it diverges by the kth term test for 59. For 60, if you ever have subtraction or addition and they're each converging, then this one will converge. And since both n squared and n cubed on bottom converge, that one will. I think that's all I assigned on that page. 8-4. I just kind of, you can pause this and write stuff down. I went ahead and wrote this for you. So it can tell you if it converges or whatever. Remember, if you want to do the direct comparison test, if the smaller or if the bigger one converges, then the smaller one will. So this is the bigger test. It converges, so I can guarantee that this one will. So it converges because of the P series with the direct comparison test. Same thing like this one. The bigger set, if the smaller set ends up being the infinity, then the bigger one must be infinity. So you can kind of look to that too. Like this one right here, 1 over n plus 1, if we compare, it diverges because if the bigger set, the bigger set's going to diverge, this one is also going to diverge. Remember, it's kind of like 1 over n. Anyway, the main thing is, let's go down to these bottom ones. They want you to figure out what these are. Well, like in 29, just simplify it first to be n to the 1/2 on bottom. Then you can say by P series, it diverges. For this one, you have 1/5 to the n, even though it's negative, the absolute value is. So that converges by geometric. This one is 3 to the n. It's really like 1/3 to the n. So you can treat it as a geometric, and it's less than 1. For this one, you can compare it to n squared, and it's going to converge. This one, the limit is not 0 for 33, so it does not. It diverges by direct kth term test. This one, you can do the alternating telescoping series. For this one, if you can integrate if you want. That's what I think I did when I did that one. And then this last one, you can integrate too, because it's n squared plus 3n, or you can do, in this one, you could actually write as telescoping if you wanted to. All right. We'll just look at just one more page. If you guys have questions, make sure you call me. I can talk to you guys individually with it. I just want to talk to you real quickly about these alternating series ones. They're easy to recognize because you have -1 to a power, okay? Now, as long as the limit of everything else is 0, it's going to converge, okay? However, I did want to tell you that, like, in this case, the limit is not 1, so it's going to diverge. And here, the limit's 0. So these three that I kind of have circled converge. This one diverges. So it's alternating, and you can look for the notes for the rest of it. Just remember, if you guys have any questions, feel free to call me. Thank you.